Unit 6, Polygons and Motion. Preview video 6.1, Part 1, Polygon and Angles. Take a moment, close your eyes, sit tall. Ready? Inhale through your nose. Hold your breath. And exhale slowly. Make sure you get a date, time, and location that you are watching this video. This is a momentous day, believe it or not. We have been camped out on triangles for almost 2 full months. And finally, this unit that we're going to be going into is going to be talking about shapes beyond triangles. So let's do a quick review of our prefixes that you should be familiar with. A 3-sided shape, prefix tri, and of course we call that a triangle. Quadri, quadrilateral. Then we start working our way up. So a 5-sided shape is a pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, and 10 decagon. Above 10, there are scientific names for them, but most often than not, we just start saying 11gon, 12gon, etc. These must be memorized. These prefixes, at least through 10. So definition of a polygon is if you have poly means many, gon means angled. If you have a many angled shape, then you have a polygon. The word regular means if you have all congruent sides and angles, then it is regular. So regular in this unit does not mean like normal. He's just a regular guy. She's just a regular gal. Regular specifically means congruent sides and angles. You need to know the difference between convex and concave, and you're probably more familiar with this in lenses in science. Convex lens is what focuses light. Concave lens, it diffuses light. Those of us who are nearsighted, we're wearing concave lenses. In polygons, a concave polygon would be something like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Both of these are pentagons. But convex means all the diagonals of the shape, any corners that you could possibly connect anywhere, are going to be inside the shape. Whereas concave means you have a side which is commonly called pushed in or caved in. The geometric definition is that it is possible to connect corner to corner and be outside the shape, as is this example. It's important to know the difference because all the equations you learn over the next 10 minutes only work for convex shapes, not concave. We would call this, chase it around, a heptagon. This, of course, would be number 4, a quadrilateral. Specifically, it looks like it might be a parallelogram. You're not quite sure without the markings. This would be a decagon. And 5, of course, is a pentagon. We're going to do a little experiment. And again, this experiment is only with convex polygons. So step number 1. We have a quadrilateral. It has 4 sides. Inside the quadrilateral, it has 2 distinct triangles. Each triangle adds up to 180. So if I wanted to find the sum of the interior angles of this triangle, I would go like this. 2 times 180 gives you 360. This one, trace it around, is a pentagon. It has 5 sides. It has 3 triangles. And when I mean triangles, I mean drawn by diagonals from a single corner. That's the rule, diagonal single corner. Each of those triangles add up to 180 degrees. Therefore, if I wanted to find the sum of the interior angles, it'd be 3 times 180, which is 540. Trace this. This is a hexagon, 6 sides. Let's trace these. We have 4 triangles from one corner. So if each of those are 180, we would go 4 times 180. And you would get 720. So there's a pattern here. There's a pattern. Watch this pattern. Number of sides, 4. Number of triangles, 2. Number of sides, 5. Number of triangles, 3. Number of sides, 6. Number of sides, triangles, 4. There is a relationship between the number of sides and the number of triangles you can create using the diagonals of one corner. So what you should notice here is that all of these are -2. So comparing the number of sides to the number of triangles, the number of sides -2 gives you the number of triangles. This leads us to our first and most important of 4 equations. You learned a long time ago, talking about triangles, that they add up to 180 always. So what if I give you a heptagon? 1, 2, 3, 4, 5, 6, 7. Pretend that is a 7th side. How would you know what it would add up to? And that's what you're going to be using. This right here is what you just now figured out, is using triangles add up to 180. We take the number of sides, we're going to use n for number of sides, -2, That will give us the number of triangles times 180. So the number of sides minus 2 times 180. This is to find the sum of the interior angles. Now think this through logically. If I had a regular hexagon, 1, 2, 3, 4, 5, 6, and all the angles were equal, if I wanted to find a single angle, I would take the sum and I would divide by the number of sides. Sum over sides. Therefore, the equation for a single angle interior of a regular polygon is n minus 2 times 180 divided by the number of sides, which is n again. N stands for number of sides. These equations are interior. Box that word interior. Interior means inside. Now we're going to talk about exterior angles. What are exterior angles? If you take any side of a polygon and stretch it out, now let's go the same direction. Stretch it out, keep stretching it out, keep stretching it out, all the way around like a pinwheel. Now, sweep the angles on the outside. These are called exterior angles. They have a very unique property. Take a look at this shape over here. If we trace angle 1, which is the purple and the blue, 3, 4, 5, and the 6th angle. If you take these wedges and you put them together, you're going to notice that they actually add up to 360. Now that's true. So if I take these colored angles, the exterior angles, and I put them together, it's going to create a circle. That's true of all exterior angles of any number size polygon. The sum of the exterior angle is simply going to be 360. The sum. That means all of them together. Therefore, if we're dealing with a regular polygon in which all of these angles are congruent, you would simply go sum over sides again. But in this case, our sum is 360, and our sides is an unknown number of sides. So we have 4 equations we're going to be working with. This doesn't make a lot of sense now, but it will. We're going to do 3 examples together, and we'll be done. But to help you remember this, because you absolutely have to memorize these equations, we have a jingle. Okay, now some of you may not be familiar with this jingle. It goes to the tune of 3 Blind Mice. I like to use nursery rhymes because most of them are familiar tunes. A few of you have never seen or heard 3 Blind Mice. So we have a very short video. Okay, you got the tune stuck in your head? I hope so. My tune will not be as lovely as that. I'm not the best of singers, but you are going to learn to sing this with me. First, we're just going to say it. Ready? The sum of interior angles, sides minus 2 times 180. The sum of exterior angles will always be 360. Each angle of a regular polygon, sum over sides, ain't this fun? The sum of interior angles, sides minus 2, times 180. I sing once, yes, and you will sing with me. You ready? The sum of interior angles, sides minus 2 times 180. The sum of exterior angles will always be 360. Each angle of a regular polygon, sum over sides, ain't this fun? The sum of interior angles, sides minus 2 times 180. Take a deep breath. Once you stop giggling and laughing, you're going to sing with me. I'm serious. Ready? Sing. The sum of interior angles, sides minus 2 times 180. The sum of exterior angles will always be 360. Each angle of a regular polygon, sum over sides, ain't this fun? The sum of interior angles, sides minus 2 times 180. As we do the next 3 problems, you always want to watch out for these key words. Okay, these key words are that you need to be careful with is the word interior. Watch for that word. Exterior, regular, sum, a notation of one or each, is, are, was. Those are all variations of an equal sign. And then the prefix is the number gone. Is it a hepta, hexa, octa, nona? You need to be familiar with those prefixes. I'm going to walk you through 3 problems. I'd like you to put your finger right here. Number 1, you're going to read aloud with me. Ready? Read. What is the measure of a single interior angle of a regular decagon? Let's underline our key words here. The word single is important, interior, regular, and decagon. Okay, you have 4 equations to work with. Take a look. First we have interior, and then we have exterior. Interior, 2 of them, exterior. So that's your first clue, is the fact that we're dealing with interior. So we're going to be looking at this page. Then we're told we want a single angle and the fact that it is regular. A single angle, regular. Therefore, we are using a single interior angle of a regular polygon, which is this. Now watch how I write the equation. Equations always have 2 sides with an equal sign. And if you fail to write the 2 sides, you're going to get these problems horribly wrong. So the 2 sides here is right here. One interior angle, I'm going to let you abbreviate, equals the sum, which is n minus 2 times 180, over sides, which is n. Now, we look at what we've been given. We want to find a single interior angle, so this is our unknown. We put our question mark here. We come over here. Deca means our n is 10. So we go like this, 10 minus 2 times 180 over 10. We're going to do this longhand without a calculator because we're smart like that. 10 minus 2, that's going to be 8 times 180 over 10. Because this is times, I'm just going to go ahead and start reducing. 10 goes into 180 18 times. So I do 8 times 18 for a single interior angle. And we find that our one interior angle of a regular, that's important, decagon is 144 degrees. Step number 1, let's read out loud. The sum of the interior angles of a polygon is 1260. What is the polygon called? Let's underline our keywords here. Sum of the interior angles. Polygon is important. Believe it or not, the most important word here is 16. What is the polygon called? This is an indirect way of asking what is the n. We don't know the n here because the word poly is generic. It means you do not know the number of sides. So keep in mind that your n is unknown. Let's look at our keywords. The sum of the interior angles. So we are working with the sum of the interior angles, this equation right here. And equations have two sides with an equal sign. So we write it like this. The sum of the interior angles is sides minus 2 times 180. There's our equation. Now, we look at what the 1260. The 1260 is not the n, it is the sum. So the 1260 goes over here, equals n minus 2 times 180. There's two ways you can do this. You can distribute this if you choose to, or you can divide out the 180, both sides. And they cancel this way. So I'm going to go 1260 divided by 180, and of course we get 7. So the left becomes 7, and then I have n minus 2. I'm going to add 2 both sides, and I end up with n equals 9. You're not done, because you're not just asked what is the number of sides, you're asked what is it called. And a 9-sided shape is a nonagon. Ready? We'll do one more. Let's read out loud. The measure of a single exterior angle of a regular polygon is 60. What is this polygon called? Keywords: single exterior. Regular polygon is 60. So let's look at what we're working with here. We're working with a regular polygon. We want a one exterior angle. So I'm here with the exterior angle. I'm working with a regular, and I want a single one. So this is my equation I'm using, and we write it like this. Remember, equations have two sides, always with an equal sign. So one exterior angle in a regular polygon, this only works if it's regular, is 360 over n. And we come over here and we ask ourselves, what is the polygon called? Which means we're solving for n, because n is the number of sides. Where does this 60 go? The 60 is the angle, so it belongs over here on the left. So 60 equals 360 over unknown number of sides. Our n here is 6, which means we are dealing with a hexagon.